everybody. In this video, we're going to be talking about the savings annuities formulas and how to use those. So take 3 deep breaths and let's make this math easy. Okay, so here's the formulas that we're going to be using. And the main one that you need to really make sure you know how to calculate is this one, because that's the one where it's the hardest to use order of operations to simplify it, just because it's kind of complicated. So just like in our previous assignment so far, A is going to be the end amount. And since the savings annuities formulas only apply to investments or savings, it's going to be the total amount that you have in your savings account or in your investment at the end of however much time you've invested it for. Then R is the annual interest rate written as a decimal. K is the number of compounds, but sometimes the problem won't tell you, like, oh, the interest is compounded this often. Instead, they'll say you're making a deposit maybe every month, or maybe you're making a deposit every quarter or every day. Usually we don't make deposits that often, but the compounding periods need to match up with the deposits. And so if they tell you how often you're making the deposits, that's what K is going to be, even if they don't explicitly say that's how often the compounding period is. And then T is the number of years, and I is the interest earned. So that's all of the formulas for this topic. And I wanted to focus in on the main formula and remind you guys about order of operations. So remember, order of operations says you start with exponents, then do multiplication and division, and then do addition and subtraction. And if they want you to do anything out of order, they'll put parentheses around it. So the fact that we have parentheses around this and parentheses around this and here means that we need to focus on those things first. So if I'm looking at this one here, this is my innermost set of parentheses, so I would simplify that before I do the big ones on the outside, because I would need to know that amount inside before I'd be able to simplify the big ones on the outside. So inside of those parentheses, I'm going to be doing the division first and then adding 1. And then I would also need to find out what my exponent multiplied together is. So I usually figure out what my exponent is first, because I like having this number in my calculator so that I don't have to write the big long decimal out, and then I can just raise that number to whatever I found the exponent needs to be. Then to simplify the big set of parentheses, I would take that result and subtract 1, and we're going to divide that by this number on the bottom. Now, the reason why we would divide that is because of this division bar here. But even if we don't know what D is, which sometimes we won't, we can still divide the top and the bottom numbers, because it's basically like simplifying a fraction. So I'll show you a little bit more about that in an example where we actually have the numbers for it. So just a reminder of where the savings annuities formulas fit in on your formula sheet. The savings annuities formula apply to situations where it does not say simple interest, where it's specifically an investment, and where you're making repeated payments or deposits, because the whole idea of savings annuities is most people don't invest a huge chunk of money all at once. Instead, they'll kind of build up their savings by depositing a specific amount every month. And so that's what the savings annuities formula accounts for. So let's look at an example. So in this problem, it says if we deposit $500 each month into an account that earns 6% interest compounded monthly, how much will we have in the account in 30 years? How much money will we have put into the account, and how much interest will be earned? So in this problem, we're actually asked for three things. We want to know how much money we'll have in the account, how much money we will have put into the account, and how much interest we've earned. So let's write out those variables. So the $500 that we were given, that's going to be our D in the formula. So D equals 500 because that's the amount we're depositing every month. And the fact that we're doing it every month, and also it says that the interest is compounded monthly, that tells us that K equals 12. Now, this part could have been left out of the problem, and we would still know that K equals 12 because that's the frequency of our depositing period. So the problems may give you that information twice. Sometimes it might leave out the compounded monthly part. But you can still find out what the compounding period is because it has to match the depositing period. And then the 6% is my R, so that's 0.06. And then my time is 30. And then this first question says, how much will we have in the account in 30 years? Well, that's what A represents, so that means I'm looking for A. Then how much money will we have put into the account? That's the total deposited. And this is different than A because the money that we put into the account is just like what we paid out of pocket. And the amount that we have in the account at the end of the 30 years is the amount we paid out of pocket, but also the interest as well. So what this is asking for is the total deposited, which we'll use one of the other formulas for. And then the interest is obviously just asking for the interest. Okay, so now that we've identified our variables, let's go ahead and plug stuff into our formulas. So I'm going to start off by finding A. And the only formula that involves A, where I know all of the information, is this one here. This formula also involves A, but it would require me to know what the interest is, and that's something that I'm actually looking for. And so that one wouldn't be helpful in this case. So I'm going to use that first big complicated formula, and I'm going to say A equals $500, because that's what D is, times, in two sets of parentheses, 1 plus my R, which is 0.06, divided by my compounding period, which is 12, raised to an exponent of the number of years, which is 30, times the number of compounds per year, which is 12, and then I have minus 1, and all of this is over 0.06 over 12 in parentheses. Okay, so to solve this on my calculator, I want to keep my big long decimals in my calculator as much as possible. So to facilitate that, I'm going to figure out what my exponent is at the very beginning. So I'm going to do 30 times 12, and that equals 360. So that is equivalent to 360. And then I'm going to start simplifying inside of these parentheses. So I'm going to say, okay, well, inside of the parentheses, I have addition and division, and I need to do my division first because of order of operations. So I'll do 0.06 divided by 12, and that equals 0.005. And if you wanted to, since that decimal isn't very long, you could cross this part out and say that this equals 0.005, because later on we're going to have to divide by that. But that really only works if your decimal is relatively short like this one. If you do the division of the interest rate by the compounding period and you get a more complicated decimal, I'll show you how to use your calculator to account for that when you do the division. But for right now, we just have that decimal in our calculator already. To finish the inner set of parentheses on the top of the fraction, we need to go 1 plus that number that we just found. So that gives us 1.005, and that's the number that this set of parentheses simplified to. So now to simplify this bigger set of parentheses, I need to take that result, raise it to an exponent of 360, and subtract 1. And exponents happen before subtraction because of the order of operations. So I'm going to click my exponent button and do 360. That gives me this long decimal that I don't want to have to write out. And I want to take that and subtract 1 from it. So I'm going to, if I just click the minus sign, that will automatically do the answer minus whatever I type in next, which is a 1. And that gives me 5.0225, etc. And where we're at now is that we have this part completely simplified. So that big set of parentheses on the top is equal to 500.02257, etc. And now at this point, you could either simplify the fraction first by taking that result and dividing by this, or you can do 500 times that and divide by the 0.005 after that. I usually like to simplify my fraction first, so I'm going to do that. So I want to take this number and divide by 0.005. So if I do the division button, I get my answer divided by what I'm going to type in next. And in this case, you could just type in 0.005 because that's a short decimal to type in. But if you ever have a decimal where that's not very simple, and you would know this because earlier on in the problem when you had already done this calculation right here, in that case, it's nice to use parentheses to calculate that like in the middle of the calculation that your calculator does. So you open up a set of parentheses and then do 0.06 divided by 12. And then you hit enter, and that number is the fraction that has simplified this part divided by this part. And so now that we've simplified that fraction, we're going to multiply that result by 500. Or you could do 500 times it, either way, because multiplication can go in either direction. So we do 500 times that answer we just found, and we end up with the number A equals 50227.52. And if we think about that, that is reasonable, because if you invest $500 each month into an account for 30 years, you're going to have a lot of money in the account by the end of that, which is what A is representing. So that's what you would do to find A. And then to find the total deposited, we're going to say the total deposited, that's going to equal D times K times T, according to the formula. So we know what T is, or D is, that's 500. We know what K is, that's 12. And then we know what T is, and that's 30. So if I clear my calculator and multiply all of those together, 500 times 12 times 30 equals 180,000. So we get 180,000 for that. And that's the total amount that we have deposited and paid out of pocket. And the reason why these numbers are so different, so this one is just over $500,000, and this one is almost $200,000. Those are pretty different because the account has earned a significant amount of interest over the 30 years. And the main reason for that is because the money that we deposited at the very beginning, in the first year, second year, that money has been earning interest and earning interest on itself over and over and over for 30 years. And that's the power of compound interest. So to find out what that interest is, we just take the amount that's in the account at the at the end, which is that $500,000 number, and we're going to subtract the amount that we put into the account, which is the 180,000 number. And I have cleared my $500,000 number. So I'm going to retype that in again. So I get $502,257.52. Subtract $180,000. And that tells me that the amount of money that I have earned in interest is $322,257.52, which is a lot of money. So again, that's the power of compound interest, because in this case, as we can see, you actually have more money in your account that you got from interest than the actual amount of money that you put in out of your own pocket. So that's how you would solve a savings annuities problem like that one. And in this problem, notice that we were given the amount that we wanted to deposit every month. In the next problem, we're going to see an example of one where that's one of the things you need to find. So in this problem, it says, suppose you want to have $150,000 saved for your child's college fund in 18 years. It says, if the account earns 7% interest, how much would you need to deposit monthly? So I'm going to underline that in red because that's one of the things we're looking for, is how much would you need to deposit? And then the fact that we're depositing it monthly will actually help us find K. And then the other questions we were asked is how much money would you invest altogether and how much interest would you earn? So writing out our variables, the $150,000 is the amount we want to have saved for our child's college fund. And so that's the amount we want to have at the end of the account or at the end of the investment. So we're going to say that A equals 150,000. And then T equals 18 years. The interest rate is 0.07. And the fact that we're making our deposits on a monthly basis tells us that the compounding period is also monthly. And there's 12 months in a year. So K equals 12. And then the question we're asked to find is what's the deposit amount? So we're looking for D. And then how much money would you invest altogether? That's the total deposited that we want to find. And the interest that we would earn is also something we're looking for. So in this problem, in order to find the total deposited, we would need to know what D is. So we could do D times K times T. And same thing with the interest formula. That one also requires us to know what that variable is. So we want to use this formula to start with to figure out what D is, and then we can use that answer to figure out the rest of the questions. So if I plug the numbers I know into the formula, A is 150,000. And then D is the thing I'm looking for. And then in parentheses, we have 1 plus our interest rate, which is 0.07, divided by 12, which is our number of compounds. Then T is 18, and our number of compounds, again, is 12. And then we have minus 1 to finish out the top part of that formula. And then on the bottom, we have 0.07 over 12. And now we use order of operations to simplify this. So remember, we start with the numbers inside of the parentheses first. And inside of these parentheses, we have addition and division. But once I figure out what that is, I'm going to want to raise it to the exponent of 18 times 12. So I'm going to simplify that first so I know what I'm raising it to. So 18 times 12 equals 216. So I'm going to raise my answer in the innermost set of parentheses to 216 once I figure out what that is. Okay, so in that set of parentheses, I'm going to do the division first. So I get 0.07 divided by 12. And that gives me 0.0058333333. And that's also what this part will simplify to. But that's kind of a long decimal that I don't want to have to type out later. So I'm going to use the parenthesis feature of my calculator later so that I don't have to type that out. So what I've done so far is this calculation right here, and now I need to do 1 plus that. So I'm going to go 1 plus my answer. That gives me that decimal, and that's what I'm going to raise to an exponent of 216. So the 3.512533 number is basically this part of my equation so far. And to simplify the big set of parentheses on the top, I need to take that number and subtract 1 from it. So that gives me 2.5125, etc. And that is basically this big set of parentheses here. Now, at this point, I'm going to want to simplify the fraction of all of the stuff on the top of the fraction bar, as well as divided that by the stuff on the bottom of it, because I don't know what my variable d is. And so I want to fully simplify the fraction so that I can solve for d. So I'm going to take this number that represents all of the stuff in the big set of parentheses on top, and I'm going to divide by, in parentheses, 0.07 divided by 12. And it's really important you put these in parentheses, because if you don't, it's going to take your answer and divide by 0.07 and then divide that answer by 12, which is a totally different answer than the thing we're looking for. So when I do that, I get 430.721, etc. And so if I rewrite my equation that I've got so far, I have 150,000 equals d times that 430.72, etc. number. And since I want to find out what d is, I'm going to divide by 430.72, etc. on both sides. So on the right-hand side, those two are going to cancel out, and we end up with d equals 150,000 divided by the answer that I had stored in my calculator before, which was the 430.72 decimal. And what that tells me is that d equals 348.25. And that's the amount that I would need to deposit every month in order to have $150,000 saved for my child's college fund. So that's what D equals, and that's one of the answers that I need. And to find the total deposited, I'm going to use the other formula right here. So I take that value for D that I just found, which is $348.25, and I'm going to multiply that by the number of compounds per year, which is 12, and then also multiply that by the number of years. And when I do that, 348.25 times 12 times 18 equals $75,200, or sorry, $222. So that's the amount that I would pay into the account in total. And remember that assuming I make this deposit every month, the amount that I'll have at the end is $150,000. And so the interest that I will earn is going to be $150,000 minus the money that I put into the account. So that 75,222 number. So if I type that into my calculator, I can say 150,000 minus, I can either type in 75222 because that number wasn't rounded. That was just the amount that I put in. And that would give me $74,778. So that would be the amount of interest that I would earn. And notice that that interest is almost as much money as I put into the account. So if you really want to have compound interest work for you, you want to invest money early on and have a lot of time in order for the interest to be earned on the money that you put in. So that's how you would do that problem. So why don't you guys go ahead and try these two problems on your own. Pause this video, see what you get, and then restart the video to see what the correct answers are. Okay, so on question 1, our first question that we were asked is how much money would you need to deposit monthly? So that amount works out to be $1,716.04. So that's the first answer. Then the next question says how much money would you pay into the account? So that total deposited is going to be, let's see, $617,774.40. So that's that amount. And then the interest earned is going to be $225.60. So those would be the three answers for question 1. On question 2, we were asked to find the amount of money we would have in the account in 5 years. So that's the variable A. And that amount will be $54,348.80. So that's the answer to the first thing we were looking for. And then the amount that we will have invested is the total amount deposited. Oops, total deposited. And that's going to be $42,000. And then the interest earned is going to be $12,348.80. And that would be the answer to the last question. So that's how you solve those two questions. If you missed any of these parts, you can skip ahead to the timestamp shown on the screen to see how to solve those. Okay, so for question 1, it says, suppose you want to have $1 million saved for retirement in 30 years. If the account earns 3% interest, how much money would you need to deposit monthly? So the amount we need to deposit is the thing we're looking for. And then we were also asked how much money would we pay into the account and how much interest would we earn. So to write out what these variables mean, if we want to have $1 million saved for retirement in 30 years, that tells us that A equals $1 million because that's the amount we want to have at the end. Then T equals 30 because that's the number of years we're investing for. And R equals 0.03 because that's the interest rate. And since we're depositing the money monthly, K is going to equal 12 because the compounding period matches the deposit frequency. And then the questions we were asked is how much do we need to deposit monthly? So we're trying to figure out what the variable D is. And then how much money would you pay into the account? So that's the total deposited that we're looking for. And then how much interest would we earn? That's the other question we're asked. Okay, so the first thing I'm going to look at is the formula that involves A, because that's one of the pieces of information I was given. And I need to know what D is in order to find the other two answers. And right now, D is something that I don't know. So I'm going to plug that in. And I'm going to say, okay, A is $1 million. D is the thing that I'm looking for. And then inside of parentheses, I have a big set of parentheses and a little set of parentheses that has 1 plus 0.03 divided by 12 raised to an exponent of 30 times 12. And then I'll take that and subtract 1, and that will simplify the big set of parentheses on top. And on the bottom, I'm going to have my interest rate divided by my compounding period again. So that's what my formula looks like. And I'm going to start off by multiplying my exponent so that I know what I need to raise my inner parentheses to later. So 30 times 12 is 360, so that part simplifies to 360. And now I'm going to focus on this set of parentheses. So in my calculator, I'm going to type out the division first, because division comes before addition in order of operations. So I do 0.03 divided by 12. Then I want to do 1 plus that. So I'm going to go 1 plus my answer, and that gives me 1.0025. And that's basically what this part of the equation means. Now I want to take that result and raise that to 360 in an exponent. So I'm going to click my exponent button and raise that to 360. And that is 2.456844 or 422, etc. And that part is this part of the equation so far. So my next step to finish simplifying this big set of parentheses is to subtract 1 from that. So I'm going to click my minus sign because that takes the answer that I just got and it subtracts 1 from it. And that gives me 1.45608, etc. And at this point, I want to divide by this stuff on the bottom so that I can fully simplify that fraction and just have d times something. So to do that, I'm going to take this result, which is the top part of the fraction, and divide by 0.03 divided by 12. But notice that I put that calculation in parentheses so that it calculates that first and then takes the upper answer and divides by it. So when I do that, I end up with 582.736, etc. And you want to keep that whole decimal if you're writing it out by hand. But that number is multiplied by D, and that gives you $1 million. So to find out what D is, which is the question we were asked because we want to figure out how much you need to deposit every month, you're going to divide both sides by $582 and 736, etc. So divide both sides by that. And on the right-hand side, those decimals are going to cancel out. And on the left-hand side, I'll calculate it by doing 1 million divided by the answer that my calculator has stored in it. And that's going to be $1,716.04. So that's what D would equal in this case. So what that's telling me is if I want to have $1 million saved for retirement in 30 years and the account only earns 3% interest, then I would need to deposit $1,700 every month. So hopefully you find an account that has a higher interest rate than that, because that's a pretty big deposit to pay every month. So that's how you would answer the first question. Then to find the total deposited, which is the next question, the total deposited, according to the formula, is the monthly deposit amount, which is $1,716.04. And that is going to be multiplied by the compounding period, which is 12, or the number of compounding periods, actually, is technically the way you would say that. And then you'd multiply that by the number of years. So I'm going to type out $1,716.04. Multiply that result by 12. Multiply that result by 30. And that tells me that the total amount of money that I would put into the account over the whole investment would be $617,774.40. So that would be the answer for that part. And then for the interest, to find the interest, I would basically take my total amount that I have at the end, which is $1 million, and subtract that number that I just found. And when I do that, so I'm going to do $1 million divided by the answer that should still be stored in my calculator. Oh, maybe I typed that in wrong. Let me try that again. 1 million minus, I think I clicked divide instead. Sorry about that. Oh, but that actually, my calculator cleared my previous answer. So that means I have to type it all out. So 1 million minus 61774.40 tells me that the amount of money that I earned in interest is, that can't be right, that's way too big. Okay, let me try, maybe I missed a zero. 1 million minus 61774.40. Okay, yes, that looks more reasonable. So the amount of money that I earned in interest is $382,225.60. So that would be what the interest would be. So that's how you would solve question 1. On question 2, it says, if we deposit $350 each month into an account that earns 5% interest compounded monthly, how much will we have in the account in 10 years? So the interest, or the information we know, is that we're depositing $350 each month. The account earns 5% interest, and it told us that it was compounded monthly, and we're asked how much will we have in the account in 10 years. So that's one of the things we're looking for, as well as how much will we have invested and how much interest will we earn. So in this case, D equals 350. Since we're depositing it each month, and also because the interest is compounded monthly, those should match. And sometimes you're only given one of those, but in either case, that tells us that K equals 12 because there's 12 months in a year. And then the interest rate is 5%. And then the number of years that we're doing this investment for is 10. And we're asked to find the amount in the account in 10 years, which is A. That's the ending amount. And then we're also asked how much we would invest, which is going to be the total amount that we deposited. And then we're also asked for the interest. So that's how we would identify our variables. And then we'll start by solving them. So if we plug the numbers into the main savings annuities formula, that's kind of complicated, we find out that A, our ending amount, is going to be 350, because that's D, times, in parentheses, 1 plus my interest rate divided by the number of compounds, which is 12, raised to an exponent of 10 times 12 minus 1, all over 0.05 divided by 12. So just like all of the other problems we've done in this video, I'm going to start off by simplifying my exponent. So 10 times 12 equals 120. So that part simplifies to 120. Inside of this set of parentheses, I'm going to do the division first. So 0.05 divided by 12 gives me this really long decimal that I don't want to have to write down. But once I've figured out what that is, I need to do 1 plus it. So I'm going to go 1 plus the answer that I just got. And that is the inner set of parentheses simplified. Then I'm going to raise this to an exponent of 120. And that gives 1.647, etc. And then I'm going to take that result and subtract 1. So that's simplifying this big set of parentheses. Then I'm going to take that result and divide by the stuff on the bottom, because that will simplify the fraction. So I'm going to take that and divide by, in parentheses, 0.05 divided by 12. And that gives me that number. And then that number can just be multiplied by 350 to find out what A is. So if I multiply this by 350, that gives me A equals 54,348. And if I round the 79 cents up to 80, that will give me the amount that I have in my account at the end. And the reason why this number is kind of small compared to the other ones we've been working with is because this investment only lasted 10 years, and the other ones that we've been doing have been much longer. So that's why the number is a little bit small on this one. So the amount that we have invested, or the total deposited, to figure that one out, that's going to be 350 times 12, because that's K, times T, which is 10. So if I multiply those together, 350 times 12 times 10 is 42,000. So that's the total amount that I've deposited. So that would be that answer. And then to find the interest, we would take the amount in the account at the end, which is the 54,348 number, and also the 80 cents, and subtract the 42,000 that we put into the account out of our own pocket, because the difference between those will be the amount that we earned in interest. So typed in the amount I have in the account, then subtract 42,000, and that tells me that the interest earned is 1,2,3,4,8.80. So that's the amount of money that was made in interest. And that's how you would do question 2.